Okay, in this video we're just going to look at some sampling waveforms. So I'm going back to the PCM transmitter at the moment, pulse coded modulation transmitter. There's our analog signal coming in. So we're looking at our sampling gate and what output we're getting in from our sampling gate. So remember, our sampling gate, all we're doing is measuring the voltage. So there's our clocks that we've got from our sampling gate clock, and if we had a scale on here, we could then work from the time period, work out what the frequency was, and then that would tell us the maximum frequency of signal that we could come in. So at these points when we've got the clocks, all we're doing is measuring the voltage so that we can then pop that in on our diagram. And so if we pop that in onto a diagram, we're then popping that in like so. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And come like so. This one here looks like that. And this one here then is going to be like that. So all we're doing is measuring the analog voltage that we've got, and then from these samples then we can then put them into our analog to digital converter. If we then look at our different modulations techniques, so pulse amplitude modulation, effectively just measuring what amplitude we've got, and we're measuring the amplitude at the center of the pulse that we've got. So here we've got a negative amplitude that we're measuring. So our pulse amplitude modulation, we should be drawing at the center. So we've got 1, 2, 3, 4 squares down, 1, 2, 3, 4 squares down, so it should look like that. This one here, I think 1, 2, 3, 4, we're going 4 squares up, so 1, 2, 3, 1, 2, 3, 4 squares up, so there. This one we're going 1, 2, 3, 4, 5, 6, I think it is. Something like that. And then this one, there is no change. So that's our pulse amplitude modulation. So effectively just measuring the voltage that we've got. Pulse width modulation. Then we're going to vary our width of our pulse depending on the voltage that we've got. So when there's 0 volts, our pulse width will not change. So we've got that, and then when we've got a positive voltage, our pulse will get wider, and a negative voltage, our pulse will get narrower. So this one here, we're getting negative voltage, so therefore our pulse is going to get narrower. I'll do it something like that. This one here, we're about probably somewhere about halfway up the scale, so I'd probably come out on a width like so, and it should be symmetrical like so. And then this one we're obviously increasing in voltage, so therefore my width is going to be a bit wide. What's going on with the pen this morning? A bit wider like so. Pulse position modulation, so we're going to vary the position of our pulse according to the voltage. So if we've got if our analog signal is 0 volts, our position doesn't change. If we've got a negative voltage, then the position of our pulse goes behind the original. So therefore this is a negative voltage, so I'm going to draw it, our pulse 2 squares wide, behind. This one is then a little bit, so I'm just going to go in front like so, and then this one is our maximum voltage. Well, it's not maximum voltage, but it's the maximum voltage that we've certainly sampled. So I'm going to go then a little bit further in front on there like so. So there's representative of our pulse amplitude, pulse width, and pulse position modulation.